Hey, this is 4.3b, linear programming constraints. So linear programming, at least we talked about it at least in 4.3a up to this point, you're going to have constraints that you're dealing with in all of these. These are kind of equations that you're looking for that should tell you where are we meeting, what is my likely area that I can shade in. Now we are going to be creating them in this section over here in 4.3b using words. Now this is super valuable. Mostly because in real world scenarios, what will happen is that bosses will not know exactly what they want or know exactly everything. What they'll be able to say is, I need us to hit this goal, this such and such goal. We can charge this much for this product. We can charge this much for this product at minimum. I need to get this out. We can only use so much time on a machine. All of these things are actually real world scenarios, and this is just kind of a little bit lower, all right, than what you might be seeing in something like a college setting or in a real world setting as well. All right, so I love linear programming. It's probably one of my favorite things that I've ever did in college. So let's kind of figure out how we can do it in a simple way that's really understandable. Okay, so constraints are inequality statements that put limits to a real-world situation that can be solved using linear programming. Every time you write an inequality to match the situation, it works as a constraint because it limits the number of solutions you can have. Okay, so you decide you want to buy a car for when you are done with driver's ed. You figure you will need it to save at least $300 a month. Now, when I hear that at least, this stuff kind of just triggers a little bit of something in my head, and we'll come back to it in a second. So I'm going to underline that for now. You have 2 side jobs. You make $7.25 an hour cleaning an office building and $9 an hour babysitting for your neighbor. If X is the number of hours at the office and Y is the number of hours at babysitting, write an inequality to show you your desired earnings. Okay, so let's start at the very beginning. They kind of laid it out in a perfect order that we need to know. At least. What does that mean? Well, it means that $300 a month is the minimum I can get. So anything that I make more is always desired. Okay, so I can't make less than $300 a month, so I need $300 to be the very bottom of my equation. So what we're going to say is whatever profit kind of equation that we have on this side has to be greater than this 300. Otherwise, I'm not doing enough to get there. Okay, so that's a constraint. That's something that we have to accomplish. Now let's figure out what we have to put on here. Now, this reminds me a lot of like our story problems that we would done in Unit 3 when we're talking about money and number of objects, right? If we did the forks and spoons problem or any of the money problems, we always had to have money times something plus money times something to give us money, right? So it's money plus money equals money. So let's kind of write out what it is. $7.25 an hour has got to be here cleaning the office, okay? But what variable does $7.25 represent? Cleaning an office. X is the number of hours at the office. So let's put X right next to that 725 just to tell us what it is. And then let's throw a plus because we need to know how much both together or added up together are going to give us. And let's say 9 is here, okay? Because $9 an hour babysitting for your neighbor. Let's put Y as the number of hours babysitting because that's what it is. And all of a sudden, look what we have. We have a linear constraint. It's saying as many hours as I work at X and as many hours as I work at Y times the amount of money I make at those jobs has to be more than 300. Has to be more than or equal to 300, I should say. Apologies there. Kind of running. Had somebody come in and talk. Now it's asking, what if your dad owns the office building and says you have to work 5 or more hours a month? Okay, this is where we still need to recall what is said here at the top. These are not separate problems. In fact, they're part of the same example. Okay, we need to ask ourselves the question. First thing, if my dad owns the office building and says you have to work 5 or more hours a month, there. Let's wonder for a second, what thing do we have, or what variable do we have that tells us that we have to work a certain number of hours at an office? What variable represents hours at the office? Well, if you go back and look, X is the number of hours at the office. So, what does that mean? Well, we have to have a constraint where it says X is greater than, and it says you have to work 5 or more hours a month, meaning that 5 is the very low ball we can go. X has to be greater than or equal to 5. Has to, in order for me to actually fulfill this obligation. This is my dad makes me work that. Okay. Now, what if your mom says you can work a max of 40 hours in a month in order to keep you caught up on school? Well, where are the hours coming from? First off, we know that hours are coming from the office. We just talked about that. And hours are coming from babysitting. What variables are we using? Well, first off, let's say we have to make working less than or equal to 40. Okay, let me rewrite that so we can see it a little bit better. It has to be less than or equal to 40. My mom says you can work a max of 40 hours in a month. Can I work more than 40? I cannot. So I have to make sure whatever this is on this side, it's less than or equal to that 40 number. Okay. So now we need to tell it what variables are we looking for that are going to give us that 40. Well, we know that X is the number of hours at the office and Y is the number of hours of babysitting. So what if we did some combination of those two? And we said, well, I have some hours of X and some hours of Y. And if I put those things together, that should be less than 40, right? So that right there is going to be our linear constraint, our linear programming constraints for this one, okay? Right here. It's very simple. If you just read the problem and you kind of have an understanding of what you're asked to do, it should be really good. It should be really nice, okay? Now, the Cupcake Boutique plan, so this is, it looks like we're going to end up explaining some things here. The Cupcake Boutique plans to purchase ads to promote the grand opening of their new store in Harriman. Their advertising budget will allow them to spend a maximum of $2,200 for this purpose. They plan to run at most 20 ads. The cost to put an ad online is $50 and $200 for a billboard ad. Let X be the number of online ads and Y be the number of billboard ads. So, explain each of the following constraints for the situation. So we can all assume that these constraints that we have here on A through D are going to be requirements that we can find within the problem. Okay, so let's think. Where can I see 20? If I go through here, they plan to run at most 20 ads. Okay, so let's understand that this is going to be some kind of ads here. And what is X representing? Well, it tells us that number of online ads. And what about Y? What's that going to give us? Number of billboard ads. Okay, so what is it telling us? Well, we have online ads plus billboard ads should be less than or equal to 20 total ads. Okay, so let's write that out. Online plus and billboard ads can't exceed, let's say exceed 20 total ads. It's ADS, my apologies there. That's pretty bad spelling on my part. I'm a math teacher after all. Okay, so that's what we're looking for right there. Online and billboard can't exceed 20 total ads. Now let's look about B. Okay, so 200x plus 50y is less than or equal to 2200. All right, let's look at what the 200 is standing for. The cost to put an ad online is $200 for a billboard ad. 50 is for our ad online. 2200 is going to be the budget we are allowed to spend is 2200. Okay, so what is this telling us? Well, money plus money has to be less than or equal to a sum total of money. Okay, so let's say let's say cost of billboard and online ads can't exceed or be more than $2,200. Okay. All right. Now this is a weird constraint. You look up top and you're wondering, I don't see 0 anywhere on here. Same thing for D. What does it mean? Well, let's try and understand exactly what X means in the first place. It says the number of online ads has to be greater than or equal to what number? 0. Well, what's less than 0? Negative numbers. Negative numbers are less than 0. -1, -2, -3. Why would we be saying the number of billboard ads or number of online ads has to be more than 0. Well, because we can't have negative numbers of ads. I can't give away ads or anything like that. It's something that doesn't make logical sense. So when you're doing this in a computer program, what will often happen is that in order to maximize cost, your computer will actually force you into having negative of something. So we have to account for that by telling it, hey, we can't have negative numbers here. We need to have positive value for these number of ads. So all I'm going to do here is say, hey, number of online ads can't be negative. And I'm pretty sure it's like. And then what does that mean for D as well? Well, what is Y? The number of billboard ads. Kind of the same idea where we have it greater than or equal to 0. The number of billboard ads can't be negative. And that's all it's going to tell you right here, okay? It's just trying to say, hey, let's make sure we don't have negative ads when we're doing our actual our summations. Then let's do one more on the back, and this is kind of where we actually have to write out the constraints for the following problem. There should be 5 inequality statements is kind of the key here, okay? So, impact, let's read it out, and let's kind of underline our lines, because we're going to probably, let's underline our numbers, because those will probably be the things that we're going to need to come back to and revisit for our inequalities, because inequalities are made up of numbers. Impact printing makes 2 kinds of computer paper using premium or recycled stock. This probably will come in handy here, premium and recycled stock. They have a contract to supply at least 5,000 cases of paper. So let's underline that 5,000 cases of paper. There's only enough stock to make 4,000 cases of premium paper, but ample stock for recycled paper, meaning that there's a lot. There's a ton of stock to be able to make recycled paper. Both kinds are made with the same machine, and 7,200 minutes of machine time are available. Premium paper takes 18 minutes per case to make, and recycled paper takes 12 minutes per case. Use this information to help you write the constraints for the situation. Okay, so let's first off start by deciding what we're going to have for premium and recycled stock. Okay, let's say that P is going to be our premium stock here. Well, let's make it actually something that we want to use. So let's say X is premium stock paper. The number of premium stock paper. And then let's say Y, this is not going to be your inequality statements, by the way. Y is going to be our recycled stock, okay? Okay, we've got those taken care of at this point. Now, they have a contract to supply at least 5,000 cases of paper. What does that mean? Well, can they supply less than 5,000? No, it says at least 5,000. So it needs to be more than 5,000 at some point. We have to say something has got to be greater than or equal to 5,000. And then they have a contract to supply at least cases of paper. Well, what do we have that? Maybe this will help a little bit. These are both paper, by the way. Okay. What variables do we have that are going to use paper? Well, X and Y represent premium paper and recycled paper. So some combination of X and Y should give it to me. Okay. So that's our first one right there. Right? That's going to be our first inequality. What's our next inequality going to be? There's only enough stock to make 4,000 cases of premium paper, but a lot for recycled paper. So let's think about this for a second. The number for recycled paper is infinite. Like I don't have a limit or a cap to it, but I have a cap for premium paper. What letter do we use for premium stock paper? We use X for that. So let's say that we have some constraint that says we have to make less than or equal to, because we can't exceed 4,000 cases of premium paper. Well, we use X for premium. So X can't be more than 4,000, which makes sense, obviously, because X plus Y has got to be greater than 5,000, so 4,000 is going to be a little bit lesser than that. Okay. Now, we've got taken care of that 4,000 right there, and that 5,000, those are going to be off the board, and that looks good to me. Okay. So, but ample stock for recycling. Sounds fine. Both kinds are made with the same machine, and 7,200 minutes of machine time are available. premium takes 18, and recycled takes 12. Uses information. Okay, we got this. So remember, when we talked about this before in Unit 3, when we talked about our totals on systems of inequalities, or systems of equations, right? Or big numbers, or the things that are totals, are going to be on the right-hand side of those equations here. So let's say that 72,000 is over here. Okay, 72,000 minutes of machine time are available, meaning, can I exceed 72,000 minutes on the machine? I don't think so. It doesn't tell me I can. So it's got to be less than or equal to 72,000. So 72,000 is going to be that upper limit for us. And now we need to measure, what is 72,000 minutes? What is 72,000 measuring? It's measuring the amount of minutes. So our equation, or the rest of this over here of the inequality, has to be measured in minutes. Well, what else do we have in minutes? Premium paper is 18 and recycled is 12. So let's talk about that. Let's put 18 here. But what does 18 represent? Well, it represents premiums. What's 18 minutes per case of premium paper? Okay, so premium is what we're going to use for X here. But then, well, we put 12 because that's also going to be minutes. And what letter do we use for the minutes is recycled paper going to be used for, because it takes recycled paper 12? We're going to use Y. And then all of a sudden we have a linear constraint that says the amount of time I spend total with the amount of premium stock paper plus the amount of time I spend total with the recycled paper has got to be less than the 72,000. Okay? So it looks like at this point that we've used up every single bit of underlying information. What could we be missing? This is where it kind of is like, these are your auto put-ins on every single one of these that you ever do. You have these automatic put-ins. Okay? Can we have negative paper? Can we have negative paper? That's not how that works, right? I can't get rid of paper to increase the amount on the other stuff. So what I have to do is tell it, my paper can never be negative. How did we do that on the last problem? Well, if you look back, we said X is greater than or equal to 0, and Y is greater than or equal to 0. So let's put something similar over here, where we have X is greater than or equal to 0, and Y is greater than or equal to 0. That tells me that premium paper can't be negative, and recycled paper can't be negative either. So we got these two check marks there. All right, now we put all of that inside a little system, and that is your 5 inequality statements right there. 1, 2, 3, 4, 5. Okay, so this might be a little bit of a different idea for you guys. I would encourage you to think about what are your totals and try and match up the letters for those things that are totaled and what they're asking for. Okay, that's the best thing that helped me when I was in college and I did this. It should help you. Now, if you need any more help, you're more than welcome to ask your teachers. And thanks. Hopefully everything made sense.